Hello, we're back. Hope everybody's come back and ready to go. We were moving along pretty well. If you had some questions that I didn't answer, or they're not there anymore, so just give me put them back in, or just like I say, you can unmute and talk to me if you want to. We've got another full day, and so I'll just start where we were, and we'll go through. All right. So we were starting on the hot water distribution system design. Again, we just talked about how the condensing boilers need condensing temperature water returned to them. All right. Then we'll move on. So heat rejection, there the tables in the efficiency tables were modified a little bit last year, but not much. And basically, we changed it we lowered the fan horsepower that required a variable speed drive or some sort of drive. And variable speed drive is probably the one you'll get. And we require the cooling towers to automatically change fan speeds to control the leaving temperature. And what we want you to do is to use as cool water as your chiller can stand, because that saves the most energy, because your fan does not use the same amount of energy as your kWs per ton do in your chiller. So it's good to drive it down to as low as we can drive it. We removed the exceptions for climate zones 1 and 2, and for some condensing systems to not have the variable speed, because we ran enough payback loads that show they pay back everywhere. We say that you need to run if you have several cooling towers, we would like you to leave as many on as possible and run all your fans at the same speed instead of turning off the flow, because you've already paid for the fill and the natural draft. So if you get your most bang for your buck by having as much surface area as you can in operation. So slowing your fans down while you leave the flow across the cooling towers is the most efficient. We have a restriction. We always have had a restriction. Cooling towers sometimes have centrifugal fans, and normally that's for cooling towers in a confined location, the basement or someplace, and they have to have extra static pressure to get the air out away from the tower. So that's fine. But if you try to put it on an open tower or something like that, then you're just wasting energy, because those centrifugal fans use quite a bit more energy than the prop fans. And this is a complicated one, but towers must turn down to handle the smallest pump or 50% of design flow. And what that's trying to say is that we do want you, if you have 2 cooling towers and you have 2 chillers, you cycle off a chiller, we want you to, again, keep the 2 cooling towers running. So that's what that's more or less saying, that the towers need to be able to have 2 on while serving the 1 chiller. The thing you have to watch on the towers are the nozzles in the top of the tower and the minimum flow through those nozzles. So that's usually the point that gives you trouble. So heat recovery, there was a bigger change in 2016, a slight modification in 2019. I just want to make sure heat recovery is a important part of the standard, and it's more and more as we go down towards net zero, you're going to need a lot of heat recovery and figure out new ways to arrive at it. So what we require, based on climate zones, the percent outside air at full design flow rate, and this is the percentages, from 10 to 20, and then this is the actual supplier CFM. So if you've got, if you're in one of the warmer climates and warmer humid climates, it's greater than 16,000 CFM of supply. This is per system. So this is one of your air handlers, 1,600 CFM, and you've got 20 to 30% outside air. You would need to have heat recovery. So there are many exceptions, and the biggest one is that if you're got your exhaust fans all over the roof or all over the building, and it'd be very expensive to duct them together to get them back to the unit, then you don't have to do anything. We've changed it a little bit so that the usable exhaust and relief was with 20 feet of each other. That's as much as we can justify for sure that it'll pay back. And it's up to you to how you do your design. But I would encourage you to not try to not get the relief in by spraying those fans out. We know that sometimes people do that, but the heat recovery, especially in cold climates, does pay back very well. Energy recovery, again, this is the same. I should have titled the rest, I would say. So the energy recovery for systems that run more than 8,000 hours per year is pretty aggressive and pretty tight. But remember, this is for units that run them quite down. We can improve the paybacks quite a bit. So it's logical that they would pay back faster, and we would cut down. That was what was that? In 2A it was 16,000. Now in 2A it's down to 2,000 for 20 to 30%. So you can see if you've got 8,001 hours, you just made a big move. Heat recovery for space conditioning. So so we've always had some heat recovery for water heating, and that was in the hospitals and prisons and stuff. But this is heat recovery for space heating. So a heat pump chiller meeting the requirements of tables 6816, which is just the efficiency tables, for heat recovery that uses the cooling system return water as the heat source shall be installed, providing all the following are true. So this is for an acute inpatient hospital. That's a 24-hour basis, inpatient medical obstetric, this kind of regular hospital. The total design chill water capacity is either heated or cooled required. A cooling design conditions exceeds 3,600 BTUH of cooling, so a big system. Simultaneously heating and cooling occurs above 60 degrees outside air temperature. The required heat recovery system shall have a cooling capacity of at least 7% of the total design chill water capacity. There are some exceptions for certain climate zones where it just doesn't work psychometrically due to ones in on the coast, one's in the dry section, and then 7 and 8 are in the very cold section. Now this was put forward by hospital people, and it is a good way to save energy in that location. Now what we normally do is put this in for these kind of spaces, and then see what our reactions are, get more data on them, and then try to start spreading this kind of thing. But what we're doing is, hospitals have strong humidity requirements, and they are often in reheat. And so the simultaneous heating and cooling for hospitals is tremendous. They're always heating, they're always cooling at the same time. So this is a very good thing if you're in the healthcare. Exhaust systems new for 2016 is transfer air. So we've always had requirements for kitchens that you make up the hoods using transfer air. So this is an extension of that. So what we don't want you to do is to put air into a space. Suppose it's equipment space that directly or a restroom that directly it's going to immediately exhaust the air we put in there. So it's much better to reuse the air from another space. So you get double duty. You cool the other space, then you take that air and you put it into the room that's going to exhaust, and then you exhaust that air out. So you can see the requirements that we have to transfer air on the same floor within 15 feet of each other, all these things, and that the air is not needed for anything else. And so it's just a good idea to try to double dip that air on the way out. Laboratory exhaust systems. So, you know, we need to probably work harder on this to get more and more stuff in there. We try to work with the lab people and make sure we move ahead. But what we've got, and we've had it for a long time, to tell the truth, is we have two options that we reduce the amount of, we slow the fans down so that we reduce the amount of air. We have variable speed, and then we have heat recovery. And so what we try to do is to allow the designer to use any kind of combination of that to meet our requirements. So if you see that equation says A plus B times E divided by M is greater than 50%. So the A is the percentage makeup air that's can be reduced, and the B is the recovery effectiveness. So we let you use a little combination of both those to meet that requirement. So here's an example of a fume hood system, and a normal one, and that's what's so complicated about these is we've got to stay that negative pressure offset here is shown, and then so many moving parts. We've got the supply from the thermostat. We've got hood sashes are open and closing, and then the room pressurization that works with this, and that's why it's a complicated system, but it complies with that requirement. This one requires it because heat recovery is not shown here, but we do control volume of air to meet the space. Non-transient dwelling units are required to have energy recovery. So this is a new thing for 2019. Again, this would be where it's an apartment type place, non-transient. It's got cooking, sleeping, and eating. And the people that make these kind of systems got together with some engineers, and they did some pretty good studies, and they show that these small energy recovery systems on an apartment do pay back. And so for a tall, we only do the ones over 3 stories, so they're kind of a big apartment building, but we do require energy recovery on them. Then these are still non extension of what we just talked about. So more of a definition, they have cooking facilities intend to stay longer than 30 days. The system has enthalpy control, at least 50% of the cooling design conditions, 60% of heating design conditions. So this is more of the details on the heat energy recovery for an apartment. So this would be other than non-transient units. So see how funny this is? To me, this is humorous because we added those 2 requirements, and we had to reword it so that everything else we do, all the energy recovery we do is called other than. And the only one we mention is the non-transient. It's funny. These are requirements for energy recovery for all other spaces. So for heat recovery for space conditioning, we described this before, but for the hospital, this is that. And then indoor pool dehumidifier energy recovery. This is new for 2019, and because of the chemicals are improved that are used around the swimming pool, we're able to do some energy recovery here. And so the people that work on those kind of systems and that sell this kind of equipment have been able that it does pay back. So it's exhaust energy recovery for the pool, and also a condenser heat recovery system capable of 100% generation through the dehumidification to heat the pool water when the pool water heating loads. So it's the air side and the condenser side of the equipment. So here we get to a really big deal. This is a 2022 deal. This is something people have asked for a long time. This is the total system performance ratio. So what we've done is we're replacing the you can avoid all of 6.5, which is the prescriptive requirements code, by doing this alternate path. Now, this alternate path is about what people have been asking for. They've been saying, if you'll just tell us, give us a BTU rate level, then and tell us to beat it, then we'll beat it, and quit giving us all these hard rules. So this is the ratio of the sum of a building's annual heating and cooling load in 1,000 BTUs to the sum of the annual energy input of the building mechanical systems, where the input units are in accordance with L5. Now, L5 is a new appendix. Section L is a new appendix that is used with TSPR, and the real rules are there instead of in this 662, because there's a lot of rules. But this is the way it works. So you'll have a proposed PSR calculated in accordance with normative MPXL. So that's your what your building's like, and then you'll have a reference file that's generated based on the kind of building you've got and everything, and then you'll divide it by the mechanical performance factor from the climate zone table, and that's the way this will work. So there are 12 systems. Well, let me step through these, make sure I don't miss anything. So the MPF factors are here. These are the things you'll divide by, and these are given to you on this table. And then the allowable systems are out of section L, and they are these 12 right here: package terminal units, VFR, VRF, those DOAS units. These are the ones that have been modeled. These will be added to over the years, but these are the ones we've gotten modeled and perfected now. These are the buildings that you can use it on. The warehouses and outpatient healthcare, hospitals, and quick service restaurants. Full service restaurants aren't modeled yet, so you can't use them yet, but we'll get those added. And then there's excluded systems that you can't use, including laboratories and the restaurants we talked about, but just some systems that haven't been modeled yet. And I could read through these, but they're there, and they're in this L when you start to use this. But systems like double duck and stuff aren't. This is all because we had limited time to get the models finished, and you'll see in a second that you do use the internet and a modeling software. Now, this is from Pacific Northwest National Labs, and they're the same people that you go to do ComCheck, and they've come up with this program to run, and it's a modeling program. They claim that it'll take about 2 hours. It's in beta testing now. And if you go to the site, if you follow this link, you can go to the site and you can play with it now. But you add a building, you put your energy code in, which is the 9.12. They also are doing this for the state of Washington, so there'll be 2 active codes in there. And then you just add your building type out of those that they'll only let you add the kind that we've already done, and then you'll set the example of the kind of equipment and system that you want to use, and you'll pick on one of these example buildings, and then you'll modify it for your building, and you you can step through, you can add different parts of the equipment with it and do all this changes. And then, like I said, about 2 hours for a complicated building, they say, and you'll be through with the prescriptive section of Section 6, the HVAC systems. So we're kind of excited about it. We think it's going to be something people like doing. And again, it's a way that we can help people, meet our goal by driving down to net zero and having more flexibility in that. We'll probably have a lot of terrible prescriptive things in there to drive us to net zero. We're committed to get a prescription. It's very difficult to have a prescriptive path that takes you to net zero. So that's why there's so much emphasis on these models and everything. Get it done somehow. All right, service water heating. So we're through with HVAC and we have a few on service water heating here. Now the service water heating does not have a simplified path, but other than that, it works exactly like the HVAC. It doesn't have an alternate path either, to tell the truth, so it's a little different. So only thing that we changed in 2019 was the test procedures for the boilers. There's been a change in that. So if you look at the efficiency tables, you'll see a little change there. We in the section for Section 7, we have requirements for the efficiency of the heaters, the boilers, and water heaters. We have requirements for how the circulating pump runs between them and a storage unit, and then we have some rules for the recirculating system and also the insulation on the tanks and the piping. So we have rules for about everything in there. Require you to run a load calculation for the hot water. Now, we don't require you to do anything with it. You don't have to meet the load. You don't have to, you can oversize, you can undersize. We can't really tell you what to do as far as that, but we want to assure that you've run it and you know the answer so that you're making wise decisions and you provided that to your owner and the owner, at least can follow what you're up to. So the equipment efficiency or the hot water supply boilers and water heaters must meet all the efficiencies. Those are in the tables, except where they have a 140 gallon storage tank or bigger. Now, 140 gallon storage is not tested by the labs. They're one-offs and they're just for your building. So all we require on those is that the tank installation is at least R12.5, no standing pilots, and fuel fire heaters have fuel dampers or fan assisted combustion. Then with piping insulation, we've got a new table for piping insulation for service water heating. We've always before just used the mechanical system. We just said insulate the same way that under the same requirements that the HVAC hot water heating piping is done. But now that we've got the on table, it's a little bit different, not too much different anyway, but it may change over time. So the equation, I think there might be even a little mistake somebody pointed up into this. This is the equation in the book, but it doesn't have the exponent here that we talked about before. And I think that's a mistake. Anyway, that'll be fixed in, it's not in the errata yet, I checked, but it should be fixed in the next go around. So the minimum insulation thickness, the material, you can see how that equation works. I just wanted to show it to you because, like I say, it makes a big difference and people don't notice. It's a little footnote on the table. So I'll show you that table in a minute. The insulation is required at these places. Recirculating system piping included the piping between the tank and the separate heater. 8 foot of the outlet piping from the tank of a storage type non-recirculating system. So just the first 8 feet, if it's non-recirculated, to get it started on its way. First 8 foot of a branch piping from a recirculated or heat traced uh, impedance heating system. So what we're saying here is you're running around the building with your recirculated system, and then you branch off to go to the restroom or somewhere to get to the fixtures using the hot water. Then 8 foot of that needs to be insulated. The first 8 foot. After that, you know, tell you to insulate. And that's a funny kind of funny because it looks like we would say how close to the fixture you've got to get, and the IACC does talk about that. Now, what we've done is we've had a lot of arguments about it, and we've decided that, we've got a whole other group that writes rules on Legionnaire's disease, so we're not gonna. You'll have to meet those rules anyway, and then if it doesn't hurt the energy and it doesn't pay back for energy, we decided not to do any more as far as insulating all the way within 2 foot of the fixtures or taking circulation within certain distance from the fixtures. As much as we can do to pay back, but we don't count the cost of water in these calculations. So if you have to run the water to get the hot water to you, and then 189 handles things like that, other codes do, but we decided not to at this point. So here's the table, the new table, and you can see that it does start at 105 degrees still, just like the heating hot water did, and table setup is about the same, but the insulation thickness, little variation, not a whole lot. Buildings with high capacity service water heating systems. So you'll see this is going to say the same thing, that if you've got a system over a million BTUs, that you're going to end up with a condensing boiler. Now, this will allow you to use a mixture of condensing boilers and regular boilers, as long as the combination comes up to this 90% average. So there's a little bit of play in there, but now condensing boilers have become so commonplace that that's probably mostly condensing boilers. So it's a really big system. So that's that. Now we're going to switch away from mechanical and HVAC, and we're going to cover everything else in the standard. And so here we go. There is on the envelope is section 5, and there is they do have some alternate paths that we'll go through and show you. So, but generally you have to go straight through. So the mandatory requirements are insulation when required in 5.5 or 5.6 shall comply with information in 5.8. So you'll see 5.8 are the tables again. Oh, 5.8 are the are how you put them in. So what we're saying is that if you're required to do insulation, you have to put in for the manufacturer's recommendations. What it comes down to, fenestration and doors the same way. Air leakage has been a big deal. It took us about 10 years to get the air leakage requirements. It's an air barrier is required now in all the buildings. It has been for a few years now. We've revised it almost every year, but it is doing a great deal, and it has helped the mechanical on the leakage. We can cut our loads due to reduction in air leakage and makeup air. So we did change in the exceptions. There was a semi-heated spaces and climate zone 0 to 6, except as required to complete the continuous air barrier in adjacent conditioning space. We found that people were, just sometimes you just have to wrap that whole area to get the air barrier to work. We've always had this exception. It's an interesting one. It's for Phoenix, Arizona, and they build a certain building with single wide concrete construction, and they would not change. They said, we're going to build that building, and so we had to compromise and give them an exception. Continuous air barrier. So this is another one of those flow sheets that I'll walk you through. But again, they're to make it simple, but there's always a little something to them. So it's for new buildings. If the building is less than 10,000 square feet, coming down this way, you've got to measure the air leakage. So a door test or something like that. If you've got a new building that's not less than 10,000 square feet or an alteration or addition, you can measure it, or you can use verification procedures. And the verification procedures have to do with the kind of materials you use and inspections that they're put in properly. So measured air leakage, when you do the test, it's got to end up that the measured air leakage of the building shall not exceed 0.35 CFM per square foot under a pressure differential of 0.3 inches of water. You'll see that a lot of times with 75 pascals when they run the test. I don't know why they like pascals better when they're giving you test reports, but that is 0.3. And the federal government requires a 0.25 CFM. So, some things are more aggressive than we have been. We dropped it, I think, from 0.4 to 0.35 in 2022, but still not super aggressive. The building contains both conditioned space and semi-heated space. You can do it, you can be shown separately, or the conditions, you can do them together or you can do them separately. Fenestration and doors. And that's, now this, the National Fenestration Rating Council, NFRC, is the people that we have built our information around, and we do require you to use them. So you can test, if you don't want to, you can test your assemblies and your doors and your windows and stuff and show that they passed. But these people have a very good set of data. You can go to their website and pick many pieces of glass. Their labeling gives everything for a modeler to use, plus everything for an inspector to look at to say, yes, this piece meets the standard. Now, a lot of buildings have assemblies and storefronts and things like that. And so these are for individual windows and stuff. So you will have to, a lot of times the manufacturer has to assemble these and give them to you in a way that equal ways. So they're just need to make sure that you have this information. So each one of these are this is 5.8, which is our requirements for construction, and so each one are referenced back to those sections, and then this will be able to tell you if you comply. Commissioning of the building envelope. The building envelope shall be commissioned, and the commissioning report shall comply. Now that goes back to that compliance section 4, but it picks up here in 592, and you can go to Appendix E for some of the references. Remember, that's the one that's an informative commissioning section, not part of the code, but it is a good reference. So, you think of commissioning as being mechanical systems and controls, but it's also envelopes and lighting. Prescription building envelope options. So this is our prescriptive section, and based on the climate zone. Now, all those climate zones are controlled by the envelope section. So that's why there's not humidity in them. But that section, there are 8 climate zone locations. There are 3 different categories of construction: non-residential, residential, and semi-heated. And there's 18 classes of construction, which is opaque elements are 14 of those. Windows are 4. And the architects are very proud that they have a 432 prescriptive requirements. So, it really is just combining all those different things to come up with that big number, but they're proud of it. So the 3 main things are roofs, above grade walls, and below grade walls. And inside of those, we have insulated entirely above deck. I'll show you the tables, but we have all these systems. So here's the table. And what we've done is we've given you 1 table per climate zone. So this is climate zone 4. And you can always tell it's section 5.5, and 4 is climate zone 4, 5.5.5 will be climate zone 5, and they're tables. So if you only worked in 1 climate zone, you could pull 1 page out of this or copy 1 page out, and you would have all you need to know about the envelope. Now, the top part of the envelope is for the opaque, which is the walls, the things you can't see through. The bottom is the fenestration, which are windows and everything. Windows are not more than 40% in all climate zones. We do have a place that shows you on every page what the wall window ratio is, but right now they're all 40%. They've always been all 40% in the basic prescriptive option. Now, in Appendix G, there's a variation based on what type of building you have. So it's a little bit different back there. Skylights are allowed to be lit. Skylights should not be more than 3% of the roof area, according to this. And it's interesting because we have a maximum amount of skylights and we have a minimum amount of skylights, and hopefully they don't disagree with each other. All right, so here's a blow up of the top half. This is climate zone 4, opaque elements only. We have non-residential, which are commercial buildings. We have residential, which are hotels and apartments. We have semi-heated, which are warehouse type spaces that are heated but not conditioned, and they're not but not air conditioned, or not fully conditioned. And in the this is another place you have to look at the definitions to understand how many BTUs per square foot it takes to stay in the semi-heated and not move into the conditioned part. So if we look at what we have U values for all the different types of construction: wall construction, roof construction. We have R values, and the R value, if you use the R values given, and even if you use brick or stucco or anything on the outside, you don't have to worry about anything else but those R values. And if you stick those straight in, then you've complied. Now, if you the R values are normally in cavities, sometimes just in cavities, but generally in cavities and continuous insulation outside that, unbroken insulation. Now, thermal transmittance is not included for the building materials and for other parts of the assembly. So again, you can just use the R values when complying with R. You don't have to worry about how big your film or your airspaces or any of that, unless it's just a whole bunch different, is what it says of a wall as envisioned, normal wall. The insulation extent has to be over the entire area of the surface or wall cavity, and it has to be the right R value thickness that makes it the R value rating. So you can't squish it into the wall or something. So if you're using U values, C factors, or F factors, then you have to use Appendix A. You have to go back to Appendix A and use the tables in Appendix A to pick your U value. You can't just make it up yourself. There's tables back there, and it tell you what the U values are for the different assemblies. You can calculate them, but if you calculate them, you have to calculate them from Appendix A9, and A9 has pretty complicated calculations. So here is this is the steel frame wall table from Appendix A, and so the way this works is here's your framing type and spacing width. So this will be that it's 3.5 inch depth, 6 inch depth, and I guess I cut it off, but this will be at right here. It would have told you that the 12-inch spacing. Oh, here they are, 16-inch spacing and 24-inch spacing. So here's the spacing of the studs. Here's the depth of the studs. All right. So here's your R value of your cavity insulation from the, if there was a requirement, say for R13 in our example, and this insulation of 7.5. This is climate zone 4's requirements. So it would be R13 in cavity, 7.5 continuous. Well, we've got 7 and 8 insulation here. This is the continuous insulation. This is the cavity. This is if you just use cavity, what it would be. This is with the continuous, so you would have to interpolate between 0.066 and 0.062 to come up with exactly if it's U value of 0.64. That's the U value from back at that table. So let's see if that's true. This is 4. This is steel frame, 0.64, . So you have to go to these tables and do it. And that's because if you look at this wall, the heat transfer through that steel stud will be much different than through the cavity insulation. And so that's that discount you're getting for that stud. All right. So this little table has always been, just after those tables, this little drawing is in the standard, and it's very helpful because this is the exterior envelope. That means that the normal insulation for non-residential or residential type insulation, and this indicates the semi-exterior, which is for the semi-heated spaces. All right, so it tells you, it helps you understand where to put it. So if you have a ventilated attic, you insulate between the attic and the conditioned space. You don't insulate it up at the top of the attic. But between the semi-heated storage and the attic, then you need semi-heated insulation. If you've gone through the semi-heated insulation to the storage, and then you just have to use semi-heated insulation for this between the semi-heated storage and the conditioned space. Down here in an unconditioned space, kind of under the house, you have to use the semi-heated, but it's not exposed to outdoors. Ventilated attic is exposed to the outdoor temperatures. Ventilated crawl space, it's ventilated, it'll take that hard insulation, the real insulation. So it's interesting to look at. If you get confused, to me, it always straightens me out. Now, a minute ago, we talked about looking at the definitions to understand what a conditioned space was. So a cooled space, which makes it conditioned, is anything that's cool that takes more than 3.4 BTUs per square foot of cooling. If you put more than that in, then it's a cooled space and conditioned. So a heated space is dependent on what climate zone you're in. If you're, it goes from climate zone 0, greater or equal to 5 BTUs. Climate zone 8, which is this is the hottest, is the coldest, is anything larger than 18 BTUs per square foot. So, and there's a table in the definitions that goes through each climate zone and gives you that number. Or if you indirectly condition a space. So if you have a transfer grill and you're using and that space is conditioned, is a transfer, it does qualify as a conditioned space. Now, the semi-heated is when it's under, it's over 3.4 BTUs of heating. This is cool, this is heating. So if you've got it heated to more than 3.4, but not a conditioned space, so it didn't fall over, if it got to 5 in climate zone 0, it would become conditioned. If it got to 18 in climate zone 8, it would become conditioned. But semi-heated is somewhere between 3.4 and what it takes to become a conditioned space. So this is a little change, but it's something that was needed to explain about roof replacements. So roof replacements where the insulation is entirely above deck shall not be required to comply with the general requirements for air leakage and replacing air barrier and doing all this other stuff, as long as it doesn't increase the energy use of the building. So this is just controlling how much the roof you have to tear off if you're just doing a roof replacement, and so it's an improvement just to make sure, just to make clear what's required. So you do have to have roof inspection reports, and you do have to be careful on your roof design. So wall solar reflectance. Now, we've never done wall solar reflectance. We've always had roof solar reflectance, but this is a test, I guess, but it's only in climate zone 0. So I think it'll move up to other climate zones, but right now, where the sun is such a big factor in the Middle East and places like that, we have a requirement so that you don't paint your building black or something like that. So we have a solar reflectance requirement for those buildings. Now, this to me is a big deal, and I think it's as big a deal as the air barriers. So the air barriers have been a major success. We issued this in 2022, and already the GSA has said that any of their buildings shall have thermal performance as critical to ensure occupant comfort and the energy efficiency of the building. Thermal performance must comply with the section 5.5, which is our air barrier section of ASHRAE 90.1, not air barrier, air thermal bridging section, which includes the impact of thermal bridging. So we base this on a new in 21 study report that was by the American Iron and Steel Institute, and it did a lot of studies, hot box studies, on the impact of metal in the walls, and so that's where our requirements came from, and they've been greatly improved. So the one I like best is insulated metal panels, because I've always had a problem with insulated metal panels. The architects will say we're using them, and I call the architect and I say, okay, tell me what the U value of the metal panel is, and they'll say it's got an R of 30, and I'll say assembly can't have an R of anything. I need to know what the U value is. And they'll say the manufacturer tells me it's R of 30, that's all I got. And it happens all the time to me, because it really bugs me that they're trying to sell. Now so they put a piece of R30 insulation somewhere in that wall, in that assembly, but we don't know anything about the thermal bridging or anything that's going on in there. But now we will, once this code gets adopted in some places, and for the GSA, we've already got it. So the assembly U factors are determined by testing. The test procedure will follow this hard thing, or they can do it by computer. U factors of insulated metal may be determined by 2- and 3-dimensional finite difference or finite volume computer models, or by testing. So now we'll be able to look at those metal panels, and an architect can pick. They'll have to meet our requirements in table 5.5, 1 through 8, or 0 through 8, that I've already showed you. And so it's going to be interesting if any of these panels fail and fall off, that have been claiming R30 and stuff like that. And also they'll be able to compete on how good of R value that are good of U value, good of low thermal transmittance that they have. So the requirements are different for each type of wall, or here's the requirements uh, for steel frame walls and all. This is it. Again, this is reference back to table A9, which is in the back, and it always references that study report, and it does have a lot of thermal bridging and a lot of way that the calculations have to be done, and so it's not a, it's not, it's going to be it's going to make sure we get the right equipment. So the section 5.5 has taxed several thermal bridges that are normal in building, and they have a different section for each one. For where roof and walls intersect each other, it's always been a problem. And it has some sub-paragraphs under the one where we have the roof edges, the parapets within the field of a roof. That means a parapet that's, halfway across the roof or separates the two roofs for some reason. Walls and intermediate floor interceptions. These are important. This is where a lot of times you'll have a balcony or something that sticks, that they poured through the wall and extends the floor space, but they're not insulating on it. Is there a question or? Page 51 of slide deck. I'll go back to that before the break. Exterior cladding support, opaque walls, and vertical fenestration. So again, holding on the cladding has always been a problem. The tabs and the braces that you put on to hold them on, opaque wall and vertical fenestration insert. This is where the windows and the wall touch each other, not having a thermal break there. Other elements of building, everything else falls in there. So there's going to be a lot of exceptions. Now, one thing that bothers me is I live in climate zone 2, and so buildings located in climate zone 0, 3 are excluded from it. Yes. So, and the reason is payback again. So, if you're in a place that has a 0 outside air temperature, and you're going to heat the building to 68 degrees, then you have a delta T across the wall of 68 degrees. And so your area times your U value times that 68 will give you your heat transfer. Now, if you're in where I am, I'll have a day that's 100 degrees, and I will want to cool my building to 75 degrees, 78 degrees normally nowadays. So 78 degrees. So that will be 22 degrees. So I'll multiply my heat transfer times the area times the U value times 22. So you can see that 22 is a lot less than 68, and so we couldn't pay back in climate zones 1 through 3 with cooling dominated climates where the delta T's aren't so big. Better the requirements for the thermal bridging. I think they'll still get at least looked at, and I know that at least we'll know what the panels will know what, if we use insulated panel, what its actual U value is, but it's still not being used in the warmer climates, or the cooling dominated climate might be a better way to say it. So what we have for envelopes is we have thermal bridging, roof to wall, intermediate wall, floor to wall, balconies, cladding support, windows, other loads, penetrations. We've also traded, and we've increased what it takes to trade off R values. I haven't really talked about that but we'll use a bigger R value in these to overcome some of the thermal bridging and stuff. And then there's a I didn't so this PSI and CHI and CHI factors. One is the PSI is for a point thermal bridging. The CHI is for a linear thermal bridging, and those factors are defined so that you can use them for modeling and doing your calculations. So fenestration prescriptive requirements. We have to, this is your glass now. Moving on to glass. And we have two requirements. One is the solar heat gain coefficient. The other is the U value. And again, these are rated by the National Fenestration Rating Council. If they're not rated by them, then you pretty much have to test the assembly. You get credits for permanent external shading. That's an overhang, and they're just, all we've ever done is overhangs. So if you use something on the side of the window or something, we've never written a rule about it. And if you have street level fenestration, we have an exception from the SHGC because the SHGC requirements can make the window less transparent. And what we're trying to do is allow for retail establishments to be able to have window, let people look through the window at displays, etc. So it's important, to understand that when we talk about low E glass and coatings and things like that, what's happening is this coating will, sunlight has this spectrum, this purple spectrum, and all of this lets heat through, has heat involved. But our eyes can only see this spectrum, this yellow spectrum. So what we try to do with those coatings and everything is to knock off as much as this useful thing that are not useful for daylighting. So we'll use daylighting through the window so that we can see without using electric lights, but we don't want the heat through. And they can actually turn these around in the colder climates and allow all the heat in, or in the warmer climates, they can block it all out. So there's been the Lawrence Berkeley National Labs has collected glass that the glass qualities, I guess is the right word. But what we track is visual transmittance. That's when it's useful for to put in light that in the visual spectrum that allows you to see, so it's good for daylighting. HGC is how much light we let in. So solar heat gain coefficients, how much heat is passing through that window. And so we have requirements based on climate zones. So climate zone 0 allows the least solar heat gain coefficient because we want, the building needs to be cooled almost all the time. And then climate zones 7 and 8 allow a lot of heat through the window because they don't need to be cooled as much. And before we had just climate zone 0, climate zone 1 and 3, climate zone 4 and 6, climate zone 7 and 8, these red lines, but now we have some variation in those climate zones. And so we have some green lines. Now, this red line was added in 2013, and it is a requirement that the visual transmittance ratio divided by solar heat gain coefficient is less than 1.1. And so everything that is right of this line is not allowed. So all these dots are a different glass. So you can see that if you're in climate zone 7 and 8, you can use any of these glasses, any of these fenestrations, any of these glass windows between here and there. But if you're in climate zones 1 through 3, you only can use this group. So you've got less to choose from. Now, a lot of times here in Texas, we'll hire an engineer, a smart architect from New York or someplace for high design, and they'll bring a piece of glass with them in this area, and we'll have to watch for that because they have to change. They can't use that piece of glass in the warmer climates, so you need to watch out for that. In 2016, we changed the climate zone for 0. As you can see, these are the green lines. So this is the max assembly SH. So used to, these were always the same, but we've got a fixed window at 22, an operable window at 20, an entrance door at 20, and skylights at 0.3. So the SHGC for these three are allowed to be different now, and so we've got the green lines. This is your maximum U assembly. That's your heat transfer conduction. So this is your requirements. You have 2 requirements for windows. Here's that 1.1 VT divided by SHGC. That's non-residential. This is the residential ones. You can see that they are all the same, at least in this climate zone. Sometimes because it's more occupied in the nighttime and stuff. Sometimes some of these will vary some. All right. So building envelope trade-off option. Now this requires there's in the appendixes it shows you a computer model, and you would have to model. It's not like as bad as an Appendix G model, but you do have to model the mechanical and the wall types, because the envelope, the way you save energy on the envelope is involved in how the mechanical system, the load on the mechanical system is. So you have to model both to use a trade-off. But the good news is that ComCheck has the trade-off option built in, so that you can go to their tables for the envelope and start putting in what you're going to do for the envelope. And if ComCheck says you pass, then you can use the thing that passed. And the trade-off options built into ComCheck. So a lot of times, even if we're not filing, for the by ComCheck, by the whole building thing, we will use just the envelope portion, do that calculation, and then print it out and include that in the design documents that we back up our design with. Any questions on building envelope? That's all we'll talk about on it. Okay. Move on then. Well, we'll have 30 minutes in that. So let me go back to slide 51 and see what that question is. Table J1, what are letters under set path A and set path B? On page 50, it is on page 51 of slide deck. All right, so we'll go there and look. Let's see if I have a way to jump fast. I will. What I want to do is I'm going to stop the show for just a second, go to page 51, and start it up again. All right, so let me see what would be the best way to do this. I don't think I have it. I've already been through it, so I must not, right? So let's see if it shows it here. So, hang on, haven't forgotten it. I just want to not explain it wrong. All right, so darn. All right, so there's not really enough of it for you to see, but there's a table J4. See table J4, chiller performance curves, section 12. And so that is on, if you do own the book, it's 361, page 361 of the book. But that's that number right there. That set right there, set path A. And there'll be, unfortunately, I don't have them all listed, but right underneath that on the table, there'll be a set path B, and a set path C, etc. So the set path is it's a description. So the set path A, tell you right about this. So set path A is so it's just a made up number that's based this description fits. So what we had was we had, for example, back here we've got saying that it's 150 tons, air-cooled chillers less than 150 tons. So we have an A and a K available to you. Now we go over here, and here's your A, less than 150 tons with those full load 10.1, part load 13. Now K is air cooled less than 150 tons with a full load of 9.7 and a part load of 15.8. And it's path B. Now that ties to the chiller table. Let me find it real quick. That ties to chiller table. Air cooled. Sorry. Liquid chilling packages. So table 6813, air-cooled chillers, path A. Now this is the efficiency allowed on an air-cooled chiller. So path A looks just like this. It is path A is 10.1 full load. That would be for the full load KW BTUs per watt, EER. So that's your full load. And then part B is 13.7 part load. So this one would be more efficient in part load and less efficient in full load. So this is the table path A from the efficiency table. Now path K, wait, this, if you went to the same type of chiller and went to the path B, which is your path B is for the one that's more efficient in part load, and have it to look at, do we? So that would be K. So you'd come over here and this weight here would be K, and it would say 0.97 full load, which is more efficient in full load, but it would have 15.8 in part load, which is less efficient in part load. So it would be a chiller that's built to run at full speed most of the time. So this top part, this set A, set path B, does tie directly to the efficiency table, but A and K are A does not tie to this A. It's just the first one listed. So I hope I got that where you can understand it. It does tie back to the efficiencies on those paths, but each one of those chillers each chiller has its own set of curves. Do that same thing and go back to 166. And if you have more questions about that, I know that I fooled around, but I didn't want to just do it off the top of my head because I wanted to verify that what I thought was true, because I get myself in trouble sometimes by saying what I think instead of what I. So I did look it up for you. I was looking at the book when I told you that stuff. I think I was right there. But do ask questions like that, please, because like I say, this is your show, and I do want to make sure that I keep it clear, and I appreciate that question. Thank you. All right, we have a few more minutes, so we'll keep going to the next section, and then we'll take our break at 12:30, or 12:30 my time, 30 minutes past the hour. So this is the power section, section 8. And section 8 has the most unliked, the most hated requirement in all the code. So this is for automatic receptacle control. We get more complaints about this than anything. People adopt the code without this section. Other people do crazy things to avoid it. But it's not a bad requirement. Knowing that, we asked the lighting people to please take this out because people hate it. And they said, okay, what we'll do is we'll give them an alternate. We'll say, you can do the receptacle control or you can do this other thing. Then they came back to us and said, no, it's too good a requirement. We're not taking it out. And the reason, well, let me tell you what it is first, in case you don't know, which I'd be surprised because almost everybody knows, but are griped about it. So what this says, the main thing it says that when the lighting controls say that this place is unoccupied, within 20 minutes of becoming unoccupied, 1/2 of the plugs will go off. So 50% of the plugs for private office, conference rooms, printing, copy rooms, break rooms, classrooms, and workstation. The plugs should be visually differentiated so everybody knows that when they leave, that plug's going to go dead. And for modular furniture, if it's just got one whip to it, then 25% of the plugs in a modular furniture would go off. All right. If you put in a power strip, it does not comply. All right. So the reason this is in here is we can get interval data from the meters of buildings. And we have requirements that when you go home at night, that we go into a night setback on the air conditioning, the lights are off, just about everything you can think of, we try to control off. And then we look at it and the building's still using 50, 60, 70, 80% of the electricity it uses when it's occupied. And we can't figure out why, if it's complying with the code. So we think it's got to be plug load. And so we're trying to attack a part that's using a whole lot of energy, and it's using it to no one's benefit. And no one should complain because they're not in the building when we turn off those machines, those plugs. All they have to do is plug something that they don't want to be without power overnight into the right outlet. And yet, it's nobody likes it. Everybody hates it. And they would save a lot of energy in their building. You know, they're not either not doing the other things they're supposed to do, or something's wrong, that they don't reduce the energy to a low amount when the building's occupied. So that's why it's there. Electrical energy monitoring. So we've had this for a while. These are sub-meters that sub-meter each of these type of systems. So we sub-meter the HVAC system, the interior lighting, the exterior lighting. There's those plugs we were just talking about. We all have a meter on the total building. And in 2022, they added refrigeration to the list of sub-metered systems. Now, by refrigeration, we mean in restaurants and laboratories and you know retail, like retail supermarkets, places like that. So big refrigeration. We've excluded like an individual. You've got a refrigerator in your office or something. You don't have to do that. But what we're trying to do is track those loads and by sub-metering those. So that's the only change to that section. Computer room systems. Now, this is not a change, but I always like to make sure you understand how this works. So power distribution systems and equipment only serving a computer room with IT equipment load greater than 10 kW shall comply with ASHRAE standard 90.4, and that means that you move out of our standard. Now, if you look at 90.4, it's going to send you back for a lot of the things we do, but it's going to have the requirements for a data center that the data center people have agreed to. We keep everything under 10 kW so that if you've got just a normal kitchen closet or a few servers in a room or something, that you don't have to go over and look at 90.4, that you can stay with our code. All requirements for data centers have been removed in 2019. Only remaining information is for computer comm data rooms and other in buildings other than data centers. That's what I meant by our communication rooms, etc. That's still under us. Transformer efficiency requirements are listed in 844. Now, these are actually set by the federal government, but again, we wanted to show them to you. And so these are good for the electrical engineers, but they're also good for us. If you're looking, how efficient they are, and so how much heat they might be giving off, you can look here and you can get a good idea of the amount of heat that would come off of a transformer in the electrical. Now, other equipment is section 10. So other equipment is motor requirements. Now, the motor requirements are listed by or something the federal government takes care of. But we gave you the requirements again, more, the electrical people, or if you're looking at the motor, you can figure out what the full load efficiency is. But again, also the heat loads from these motors would help you to know how much is rejected by heat. So we try to give you all this information, and so you can use it to meet two different needs you might have. We also have, for the first time, regulated elevators. Now, For elevators, we regulated these to we've done it in 2 steps. So previously, what we did was we had the person picking the elevators had to schedule on the plans, had to look at the ISO 25745-2, and the information from those tables onto the plans, where he picked it and what the energy efficiency class was, et cetera. So it supposedly got someone picking these elevators by the 2019 code, it got them familiar with the tables. Now, what we did in 2022 was we made an actual requirement, and the requirement is the energy efficiency class shall be E or better per table 7. So it's important to us, not only do we have minimum efficiency for elevators, which will scrape off some of the worst elevators built, we had to meet with the elevator people quite a bit to get to the point where we could do something like this. Now, the other thing it does, though, is it allows that to be a regulated load. So if you remember the calculation for compliance with the standard when you're running a model and stuff, is that your regulated loads are multiplied by that factor. And your unregulated loads stay constant all the time. And those unregulated loads end up in the denominator because you divide through the denominator. Anyway, the denominator because you divide through it all the time. And if the denominator is bigger, then your savings are smaller. So if we move it over there and multiply it by that factor, then it makes a bigger impact than just the energy savings for the elevators. It also makes an impact on the the whole total calculation, a good impact. So we also have elevators, lighting, ventilation, and standby mode. So for the lighting, we allow you 50 lumens per watt. Now, in 2019, we only allowed you 35 lumens per watt, but the lighting subcommittee this was set by the mechanical subcommittee, and we've been doing all the work on elevators because it's a motor, so they thought it was us. But they came and said that they believed that was too low for an elevator. So we've actually increased the allowance for the lighting in an elevator in 2022 up to 50 lumens per watt. Now, the ventilation, we require just 0.4 CFM per watt. That's the efficiency of the fan. It's got to produce 0.4 CFMs for every watt or more. Standby mode, if nobody's using the elevator, we want what it says to do is to open the door, de-energize the lighting, and turn off the ventilation. So it'd be a dark elevator with the doors open. A lot of people return it to the floor. I don't think we tell them they have to return it to the first floor, but that's the standby mode. And then escalators and moving walks. So we require the escalators and moving walks to have, you can see here that they have eyes there in front of the post. This is in the Tokyo airport. And so as you walk up to this escalator, it'll start up and it'll stay off when there's nobody around. I was working in Vietnam for a while, and I would go through this Tokyo airport all the time. It would be an early flight, and I would be the first one to arrive, and I would be walking through and turning that escalator on all the time. So I took a picture of it because it worked to illustrate an escalator that met our requirements. So I think what I'm going to do is we're going quick, and we got some time left. So I think I'm going to give you a 15 or equivalent to about a 15-minute break now, and so that we'll meet back at 12 at 40 after the hour and start back up. So if that's okay with y'all, let's take our break right now. It gives you that extra 15 minutes and still lets us start at the same time. Now you're down to 12. Anyway, so I'll see you at 12. We're still in section 10. It's 10.45 now. This was a new change in 2019. So we've always had a requirement for vestibules for most doors. And it's got to do with climate zones, and a couple of other things can change it. So the air curtain people came to us, and it took probably 3 trips for them there, plus a lot of emails and a lot of papers. But they had a lot of studies that they had done, and it was decided that an air curtain could be as good as a vestibule for our requirements. And so now, in lieu of putting in a vestibule, if you want to, you can use an air curtain. So this was added, is section besides 10.4.5 where we explain air curtains, it was added to section an exception to the vestibules in section 54343 if you look in the envelope section. So self-closing doors in buildings in climate zones 0, 3, and 4 that have an air curtain comply with section 10.4.5. So it's got to be a self-closing door. It's got to have a closer. Self-closing doors 15 stories or less in climate zone 5 through 8 that have a air curtain comply with section 4945. So the stack effect of a 15-story building, of a 16-story building, was too much to overcome by the air curtain side. So we disallowed those on the colder climates. Now, this is not an air curtain on an open door. It's not like, we hold the doors open and we blow the air curtain, and it's the air curtain that's replacing the door. The air curtain is with the door. So if the self-closing door opened, the air curtain would automatically come on, and then it could turn off after the door is closed. Compressed air systems. This is new for 2022. It is again, we are moving into something that could be considered a process. We did the same mistake we did with the computer room systems in a way. We did try to contact a lot of people because we knew of that problem that are involved in the compressed air business, and we obviously talked to the manufacturers and all that stuff. But again, not everybody that owns a large compressed air system and does industrial work with it knows that they've been regulated. And so I'm personally worried about it, that we're going to get in trouble again by surprising a large owner that all of a sudden, he has a bunch of rules to meet that he's never known he had before. Because a lot of people in the industrial world are not paying a lot of close attention to our requirements just in their office building sections. But in their plants, they're claiming exclusion because of the systems are in for the process. Now, if they've got good people on the energy code wise, then, we ask questions like, oh, so you put lighting in so your machines could see where they're sitting or what? No, those lights for people. And so the light has to meet our requirements, and there's things that have to meet our requirements, even if the air conditioning system is actually there for the equipment, not the people, and would not have to meet our requirements. Anyway, requirements are for the compressed air system, not the process system, or not how they use the compressed air. It's just for the compressed air system. It's part load there's part load requirements for systems over 25 horsepower. There's control requirements for optimizations of systems with 3 or more compressors and more than 150 horsepower, how you turn them off, what size they have to be, the steps between the compressed air systems. Systems with 150 horsepower or more shall have a monitoring system so that it does let the controls people or the operators know how those systems are working and if they're working the way they should. Systems must be leak tested, and for pipes longer than 50 foot, they have to be sized at and 50 psig, pressure rating. They must be sized to minimize pressure drop. We give them a sizing table, and there's an exception for medical gas and a few other exceptions like that for places we don't want to get involved in controlling the compressors. On-site renewable energy. I told you before, but here it is in 10511 is the first time we've ever required renewable equipment. It's got to be sized to generate 0.5 watts per square foot or 1.7 BTUs if you're making hot water, times the gross conditioned floor area of all floors up to the 3 largest floors. And that's the first time we've ever required. Now, there are some exceptions, and most of the exceptions have to do with that there's not room on the roof is shaded, that you can't put it in, and there are some exceptions for that sort of thing. So now we're going to start section 9, the lighting section. I wanted to look at something real quick because I had asked myself a question. I don't think it's in yet, but we've been working on a change to a change to our renewables. So let me very quick confirm that I'm right, that it's not in yet. Any building more than, any building where more than %, new construction, buildings less than 10,000 square feet. Okay, so there is not any exception. Let's see, oriented towards. So I was trying to remember. We're working on some exceptions for things that are, where you buy all renewables and you do a lot of stuff like that, and you have long-term contracts and things like that. We're working on some of that stuff, and I wanted to make sure that it wasn't in the 2022 code, and I just checked, it is not. So the requirement, there's no, you can't just go say, well, I'm buying renewables from my supplier, power supplier, and get out of that. That's not one of the ways you can get out. All right, so here's lighting, and lighting is now very, fairly complicated. We have daylighting through the sun. We have external shading. We have controllers that control how, dimmers and things that control that based on daylighting. We have timers. We have occupied, unoccupied. We have a lot of things going on. And now we haven't yet, but we will be adding the power grid into this in 2025 because we're working with, signals from the power grid, and we're going to have those included in the 2025 section. Scope of requirements. That we have interior spaces of buildings, we have exterior building features, and we have exterior grounds lighting provided through the building's electrical service. So this has always been a problem, for parking lights and things like that, especially because we regulate through that building's electrical service. We try to go along with construction and permitting and everything. So if you've got another electrical service that doesn't serve the building, then then some of the requirements, you can avoid some of the requirements. But we're picking that up now with that site lighting. So even though this is through the buildings, ground lighting through the building electrical service, it will probably be changing now that we're at site, and parking lot lighting has been changed. All right, so lighting alterations. Alterations for interior, this is always comes up because people want to improve their lighting, and we've got they say we've got too much rules and regulation that's slowing them down from improving their lighting. So alterations for interior building spaces, the alterations of a lighting system in an interior space shall meet one of the following. The alterations shall comply with section 9.2, which is, we'll show you in a second, but it's when the total wattage of all, total wattage of all new and retrofitted luminaries are greater than 2,000 watts. Before, it was 20% of the connected load. When the total wattage of all new and retrofit luminaries, so that was one, you meet that one, and you have to comply with 9.2. 9.2 is going to trigger you to do the controls, things like that. People don't say, well, I want to make this change to make my lights better, but I don't want to go over and get to the switches and change the controls. When the total wattage of, this is B, when the total wattage of all new and retrofitted luminaries is 2,000 watts or less, each altered space shall comply with the light power allowance, which is how much power you can use for lighting of tables 95952 in section 9522. People don't care about that because they're normally improving their lighting. Or the alteration shall result in a new wattage of at least 50% below the original wattage of each altered lighting system. Additionally, the new and retrofitted lighting system shall comply with the control requirements of 94941. So that's where, see, we get them again. And each altered space is shown in tables. So again, you can't do something that improve the lighting up to 50% without doing the controls, and that bothers people. So here's lighting alteration for exterior building are about the same kind of thing. The alteration of a lighting system for exterior area shall use only area-specific allowances. That's our table. That doesn't bother people. Alterations comply with 9.2 when the total number of new and retrofitted luminaries is greater than 10, or the combined length of new and retrofitted linear luminaries is 20 linear feet. And then B, when the new retrofitted luminaries are not greater than 10, but you still have to do, you still have to go to those tables and do that work, and that means controls. So, lighting power trade-offs. Separate requirements exist for exterior and interior lighting. Each system must comply separately with their respective requirements. Trade-offs between exterior and interior are not allowed. You can trade off interior lighting among the spaces interior to the building. Exterior lighting, I'll show you on some that are non-safety or excluded, can be traded. Now, when we talk about wattage, we mean the lamps, the balances, the transformers, the control device. It's not just the lamps. Lighting, track lighting is lowered because of the wattage is lower in those lamps. The track lighting is lowered from 30 watts to 10 watts a foot. So before, if you had a track, we would allow you 30 watts per foot of track. Now we only allow you 10 watts per foot of track. So the compliance process, there is not an alternate path, but there is a simplified method, and then all the normal methods for lighting. So this is interior lighting. These are the exceptions to interior lighting requirements, and you can see that sometimes. So lighting is integral to equipment. Well, this makes sense. So you've got a piece of mechanical equipment, medical equipment, or instrumentation that is installed by the manufacturer. So a big bright light for somebody to operate by or something like that. We don't have any control requirements. So it's got to be an addition and separately controlled from the normal lighting, and then it qualifies. If it comes on immediately when you turn on the light in the room, then then you have to, it all of a sudden gets under the control requirement. So you can see we have several of these things where it makes sense, for to not be in. But then we get down here to places like open glass enclosure, refrigerator, freezer cases. It's separately controlled, but it's still going to have to go to automatic shut off. That lighting's got to be either shut off when there's nobody around or scheduled to be shut off. So, those are the requirements. Keep going on, furniture mounted. So we moved these and listed them separately like this, just made them clear. All right, new for 2019, simplified building method compliance path. So all that we've done, all that the lighting people have done so far is come up with a simplified path for office buildings, retail buildings, and school buildings. And the simplified building method contains the requirements for interior lighting and exterior lighting, and shall be allowed to be used where at least 80% of the floor area supports either office building, retail buildings, or school buildings. Simplified methods shall be used for new buildings or tenants, improvements of less than 25,000 square foot. Interior and exterior wattage allowance shall be calculated separately. So if you've got a simplified building that's an office building, these are the requirements. And so the light power density in buildings other than parking garage shall not exceed 0.56 watts per square foot. And that's for the whole building. And then all lighting shall be automatically controlled. So these controls are simpler than the controls that, the full blown controls. Mainly, they don't have anything about daylighting and some stuff like that. So this is a simplification, although it's not, it's not tremendously less simplified. It is a move in their direction. And then they have retail buildings, and then they have school buildings. So the retail buildings, again, everybody has some controls, and that's what most people complain about, is not really the lumens cost of controls. So you can see there that retail buildings, do have some improvement. And this number is just one number you have to meet. School buildings, same kind of thing. And again, still too many controls, most people say. Exterior lighting for the simplified method, I'll go through, you haven't seen the normal table, so you don't know much about this. But anyway, it's a little simplified, but not much. All right, so here's the mandatory requirements. Go through this in some detail. So the big change in 2022 is that this is used to, it had to have 3 steps. Now it has to be continuous dimming. So you turn it on and you can go between 110% to off, and it's continuous dimming, automatic continuous dimming based on daylight response. So this will be your multi-level control. It'll be automatic if we got a daylighting system in this space. So what we want you to do is we want you to come in the room and we want you to turn it on. We would rather you look at the room and say, I need more light, and turn it on, then it work automatically. Now we do allow up to a half automatic on, and that's that we just allow it. So some spaces have only manual on, some spaces have partial automatic on. Then we have the multi-level controller that I've already talked about. That's the main change in 2022 besides the amount of power we allow for lighting. Automatic partial off, full off complies. So at least 50% have to go off under this and off, and then we have the automatic full off. But within 20 minutes of the space being vacated, it goes off. We can also schedule it through some sort of computer system. We can schedule the turning off. Now, for daylighting, we require, the way you do it is you measure up to the top of the window from the floor. That gives you the height of an area. So you lay that, this is the section view. This is the window in the wall. Now, this is the plan view. So you take that height and you lay it down right here, and this is your primary skylight area. It's a distance between the floor and the top of the window. You lay it down. That's your primary area. If there's a block or something where this is like a wall over here, this window couldn't go that deep, it's okay, you just block it off. Now, you have to take that same length and lay it down again, and there's your secondary highlighted area. Any space where the combined power input of all general lighting, completely or partially in with the primary, 75 watts. And add secondary sidelight areas of the combined area wattage of no greater than 150 watts, then you have to have skylight, you have to have daylight. So the general lighting of the primary and side lighting areas and secondary lighting areas shall be controlled by photo controls. So this is a separate control system for each one, and each one is has a dimmer, 100%, 0 to 100% dimmer, that it's using to supplement the lighting it's getting from the. And these pictures and most of these requirements come from the definitions, come from section 3, the definitions of And we have the similar type thing. I haven't showed it to you, but there's no changing for top lighting, but we have the similar set of pictures in the definitions for skylights that show the shape of the area underneath the skylight and the requirements for that, and what to do if your skylights overlap your secondary, your side lighting. Why that jumps by itself. Anyway, so now parking garage lighting control. You're in your parking garage, and your lighting shall automatically shut off if there's nobody in the parking garage, no movement at all, then we're going to turn off some lighting, and we're going to do it by small sections. Lighting power at each luminaire should be automatically reduced to a minimum of 50% when there's no activity detected with the lighting zone for 10 minutes. Lighting zones for the requirement should be no larger than 3,600 square feet. So we won't go to 0 because that would be scary, but we will turn it down. Parking garage daylighting, transition zone lighting shall be separately controlled to automatically reduce the lighting to no more than the general lighting level from sunset to sunrise. So now what this is that from when it gets dark outside, we want your eyes to dilate. Does that make sense? But no more than general lighting level from sunset to sunrise. All right. So when it's daylight outside, bright daylight outside, you're coming out of a dark parking garage, and when you hit the street, you can't see because your eyes haven't adjusted to the daylight. So right before you leave the parking garage, many times there'll be a whole lot of light, and that'll cause your eyes to contract and get ready to go out into the sunlight so you'll be able to see when you hit the street. And what this is saying is that's fine. We know you need to do that for safety, but when the sun goes down, you got to turn the extra light off because you don't need that light when it's dark outside. The power to any luminaire within 20 foot of the perimeter wall opening. So you're in a parking garage and it's got a hole in the wall, and at 20 foot of that opening, you're going to use daylighting. So that between at least 24 foot from that opening, it will automatically reduce through continuous dimming in response to available daylight. Dwelling units. So this is the first time we've reached into apartments for lighting. Not less than 75% of the permanently installed lighting fixtures shall use lamps with an efficacy of at least 55 lumens per watt, or have a total luminaire efficiency of at least 45 luminaires per watt. No other provisions from Section 9 apply to dwelling units. So just efficient lighting. Now, horticultural lighting. This is a big load now that in some states there's a lot of horticultural lighting going on. What's interesting about this regulation is it is completely different than people. Plants care about photons, photosynthetic proton efficacy, PPE, of at least 1.7 millimoles per joule. So, to me, that's very interesting because the plants, the people see this area lumens. That helps us see, but a plant perceives all this other light, and all they're picking up is photons to use in photosynthesis. So, to me, that was fairly interesting. We have a 1,000 watt high pressure sodium lamp meets the requirement. We have two different requirements. One is for indoor grow spaces, which means there's no daylight getting in at all, and the other is for greenhouses, and that's a little bit different because the amount of light coming in, there is light through the greenhouse. So anyway, to me that was very interesting. I did not know about the photons until we started regulating this. All right, exterior building lighting power. So this is the tables for exterior building lighting table. Now they vary by lighting zone. The exterior lighting zone start at line 0, which would be like a national park or a state park or a place where it's supposed to be nature. And we don't allow any lighting in those spaces. Now, inside the national park, there may be a place with lodges, etc. And we do require we do allow those to be lit by a climate lighting zone 1. Lighting zone 2 is residential neighborhoods. Lighting zone 3 is all other areas, and lighting zone 4 is highly active commercial districts in major metropolitan areas as designated by the local jurisdiction. That would be like Times Square or the Strip in Las Vegas, something like that. So here are those lighting zones. We have those 4 tables. This column was added in 2022. This is a column that tells you what controls are required for each one of these places. All right. So this is first page is called the tradable surfaces. So the surfaces that if you have a walkway or ramp or a plaza area, you can get so many watts per square foot for it, and you just go through this whole thing. Anything you have, you multiply the areas by the wattage, and then you have this big bunch of wattages, and you can use it any place you want to. Now you can't say I don't have a plaza area, but I want that anyway. No, that doesn't work. You have to multiply by the square foot you actually have. But then how you apply it, you can apply it to any one of these spaces. So you can spread it around. We give you, to start with, we give you a base allowable. and you can use that any place you want to in the tradable or non-tradable surfaces. But this has been greatly reduced in 2022. These numbers are much lower than they were in 2019. So that's your base allowance. All right, now this is the non-tradable. These are, use it, you got it, you can use it there, or you can't trade it, you can't give it anyplace else. Starts with facade. So if you want to light the outside of the building, you can, but you can only use this lighting for facades. Second, we've got automatic teller machines. That's obviously for safety, and you can't use it anywhere else. Uncovered entrances, a gatehouse, and inspection stations at guarded facilities. Obviously, that's for safety. Only use it there. Drive-through windows and doors, parking garage, parking near 24-hour retail entrances. For areas not listed in the table that are comparable to areas listed as table, which means security type places. You've got some power untradable. All right. So then we'll go to the interior. First kind is called the building area method. It's for whole buildings. So if you have a dormitory, you can use 0.52 watts for the whole building. And then you're through. It's pretty easy, right? Any of these, there's many office spaces listed or many kind of spaces listed, and each one has just one number. You take the area. So this one is 100 square feet by 90 square feet, 9,000 square foot little office. And this 9,000 square foot little office in 2004 was allowed 1 watt a square foot or 9,000 watts to light this building any way they wanted to use it inside the building. Now, by now, it's come down to 0.63 watts a square foot in 2022. So only where it was 9,000, now you're only allowed 5,670 watts to light the building. So it's been a very good reduction. All right, the next way to do it is a space by space method. So if you have an office building, so you could have used the office building type, and you could have put that 5,600 watts anywhere you wanted to in the common areas and the tents, spread it out any way you wanted to. But now you have the choice of taking each little office and the common area and the hall, etc., and using a wattage level for each one, and then add them together. And again, you can trade them between the surfaces, so you can move them any way you want. Now the table for this is a nice table. It has everything you need to do the design for space by space method in this table. So here we go. Let's just look at an office type for now. So lighting power density. This is how much watts per square foot you're allowed to use for lighting the space. Now, the next is room cavity ratio. This is an equation you can run. I think I've got a slide on it coming up that just says, all right, so this space is long, narrow, and tall. And it'll look like a cave if I don't put some extra lighting along the walls and stuff. So it gives you extra amount of lighting based on if the equation you run that has to do with perimeter and height and stuff comes up with a number greater than 8 or 4 or different, whatever this number is here. So it triggers that extra percentage. Now, this is the local control. It's required. This is manual own. And this is partial own, partial auto own. These are called add one, add one, add one, add one. You get your choice. For an office, you can use either one of these you want to use. And it's your choice. You use one or the other. Then this is required. Multi-level lighting is required. Daylight response is required. All these are required. And at full auto off or scheduled off, Now, some of these you can see have an add to. So this one says I can turn it off, either auto full, or I can have a schedule. This one only allows full auto. It's not allowing the schedule. All right. Room geometry adjustment. This is the RCR, allowed in the space by space method only. The lighting power density may be increased by 20% when the RCR calculated for the empty room is greater than the threshold listed. So like the 8 and the 4. So that's a room cavity height times the room perimeter length times the room area, where the height is equal to the luminaire mounting height minus the work plane. So that would be your desktop, something like that. Exception. For corridor transition spaces, this adjustment is allowed when the corridor is less than 8 foot wide, regardless of the RCR. So you can get 20 extra. If you got a 7 foot wide corridor, you can get 20% extra lighting just to keep it from looking like a cave. So here's a picture of a corridor. Now, all the lighting we've been talking about is this lighting here. This is general lighting. This is this is what is on one switch, has to be controlled by itself, and what we're talking about in all those tables. Now, this is lighting for artwork and spotlighting for accent pieces. This is, if it's switched separately, it can be added and it's not included in this number at all. It's been reduced from 1 watt to 0.75 watts in 2016 and further reduced from 1 watt, 0.75 watts to 0.7 watts in 2022. So it's going down, but at the same time, these lights, these are now LEDs and all that other stuff. So you get probably as much bang for the watt, as much light out for this less wattage as you were before, but it is coming down. Now, some of the other exceptions besides the one we just talked about, this is the decorative lighting we just talked about. Retail sales lighting. So retail sales have 750 watts extra. This is to spotlight the products you're selling. And then for the area itself, so retail area 1 is times 0.4 watts. And that is all other products. Retail area 2 is vehicles, sporting goods, and small good electronics. That is another plus. If you have that area, you can add that. Plus retail area 3, which has furniture, clothing, cosmetics, and artwork. And retail area 4 is jewelry, crystal, and china. So see, you get 1 watt a square foot for jewelry and china. 952 allows additional power for non-mandatory controls. So that's just another place you can get some extra power. If you want to put in, there's a little bit of a table that shows you, but if you want to put in something that's not a required control, but that'll save energy by reducing the time that the lighting is on, then you do that, and you can get it'll tell you that you can get a little extra wattage to use for reducing the amount of time it's running. Verification and testing. We do require verification and testing on for the lighting. It's very important. We had a lot of trouble, especially for the daylighting controls, that it wasn't tested, didn't work right, people weren't saving the money they had hoped to save. And so now we've required a lot of testing, commissioning, and hopefully everybody's getting the systems that operate properly. So you have to, your occupancy sensors, your automatic time switches, daylighting controls, high-end trim and lumen maintenance controls. And there's limits on who can do it. The person doing it could not have been involved in design. They can work for the same company as it was involved in the design. And they do have some requirements, that they have to sign some paperwork. The energy performance of the building lighting shall be commissioned in according with the with the requirements of the section and getting that's in section 4. Commissioning report shall comply with the next section, section 4. And you can look at Appendix E. We've mentioned this a couple of times to get some more commissioning references, and H for commissioning guidance. All right, that's the end of that. Let me make sure you don't have any questions. Look, oh, we do have some questions. Letters under the interior fit out. Can interior fit out project use simplified building method, or only complete building project can use this path? So the interior fit out can use. Let me check, double check. You're talking about the lighting and whether it's whether it can fall under that. Let me double check that for you. If I didn't say that, I'll make sure. Let me look real quick. That was let's see, escape. Let's double check. Simplified method. Let's go to this one just for well, say it here. Simplified method contains requirements to be used in this allowed use buildings. Simplified method used for buildings are tenant improvements. So for tenant improvements of less than 25,000 square feet, you should be able to use it. I think that's your question.
Yes, that was my question. Thank you.
All right, great. Can retail additional lighting be used to trade off for another space? It sounds based on your previous, no, that can't, because I'll show you why. Let's go back where we were. So, all right, so this is times, well, so see retail area 4. And what we mean by retail area is the square footage of that area. So you're supposed to use it inside the area that we're referencing. Now this top, the 750 watts, could be used anywhere in the retail area, but it couldn't be moved like if there was offices behind the retail sales, you couldn't move it back into the offices. It has to go into the, originally it was very detailed on saying it had to be put in the actual area of the display. It's not quite as clear anymore that it has to be used in the actual area of the display, but it is called the retail area. So it does reference floor area used for the sale of vehicles. So it's supposed to be multiplied by that watts per square foot of the actual area used for this sale.
My question is my question is not about the square footage, how to determine the square footage. It's about can we use that additional credit for other places? Like when you do calculation, right? For example, if I have retail space and I have office, I put too much of my right? Can I trade off the lighting in the retail area? Based on the ASHRAE compliance form, then no, you have to be in the same space. But contract, so I really want to know, like.
Okay. I'm having a little trouble because you seem to go kind of up and down a little bit on my ear still, but I don't have I'd have more to do with, I don't have my earphones on, I'm listening to you through my computer. But I think what you're asking me is that maybe your comm check was working different than what you think I'm saying here, and you're wondering about something about the area, but I like I say, let me put, well, my earphones are over here.
Or maybe I can just give you an email if you don't mind.
Yeah, just why don't you type it in a little bit or whatever, or send me an email. At the end of the show, my email will be there. I'll be happy to, I always reply to any email I get, or you can type it in here, either which way you want
Okay, great. Thank you so much.
to go. Okay. Let's go back to where we were, which is pretty close to here. So now this is a brand new section. This is called additional efficiency requirements. So if you've been using the IECC, you've seen this type of thing before, but we're doing it a little bit different than they are. But but it is the same thing that you're used to, in that you have to, after you've done everything you've normally done to comply with 90.1, you have to do additional efficiency requirements to be in full compliance. So, and this is something that we have never done before, but we're trying to get to net zero. So why this was important to us, besides making the building a little more efficient, is there were things that we wanted to try to get into standard requirements that could not get in the standard because we couldn't get full agreement on. Now, what we could say when we were working on these type of things is we can say, well, the person using it doesn't have to do that one. They can choose another one. So we're not forcing them to do this. We're just putting it as one of the options they can do. So it doesn't have to clear its high hurdle. We can get it in the requirements. And then maybe later on, if people are using it and it's working well, it'll move up into the general requirements and something will replace it. So that's one of the ideas. It's a strategy to get things in the code that wouldn't quite meet everybody's approval. So this is the way this works. Each product must achieve the total number of credits required in table 1151. That's this table. We will work through an office example. Climate zone 2A, 50 points. So here's an office, climate zone 2A. You have to earn 50 credit points for it to comply. So the second table is energy credits for office buildings, and we have credits. E is for envelope. So you look over here, if you want to improve the envelope, you pick an E credit. H is for HVAC. We have 1, 2, 3, 4, 5, 6, 7 choices under HVAC. W is for service water heating. We have 1, 2, 3, 4, 5, 6, 7 water heating. 8, 9 water heatings. All right, P is for power. There's only one of those. L is for lighting. 1, 2, 3, 4, 5, 6 lighting. Q is for equipment. We have 3 equipments. R is only 1, on-site renewable energy. And G is for load management. And we have 7 load management. So each credit has a section in the standard. Some are just I did it or I did not. Some are calculations. So H07 is improved HVAC sequence of operations. To achieve this credit, all the control sequences shall be based on ASHRAE 36. Many people are know what 36 is. 36 is a guideline. And a guideline cannot be specified. We cannot say you have to meet a guideline in a standard that's used for a code, because that codifies the guideline, and the guideline is not done in a way that it can be codified. So, but we can reference it and we can do it in this format, and we can say, if you used it, then we'll give you 3 points. Now, some of the things in 36 I agree with and good, some I don't, but this would cause you to do all your controls by 36, and you only get 3 points. So that would be a decision you'd have to make, but it's only I did it or I didn't do it. Now, this is HO3, which is cooling performance improvement. Now, it says, if we look back at it, it'll say that we'll get HO3 cooling efficiency, section 65223. You can reference back to what the real requirement is. In 2A, you'll get 12 points. Now, what that means, though, is that you will get 12 points for going at 5% better. So you look up, you get the piece of equipment out of 681, and you improve that efficiency by 5%, and you would get 12 points. So you pick your piece of equipment, you schedule it on the plans, and an efficiency 5% above what's in section 681, and you get 5 points. Now, though, if well, I'll tell you in a minute. So that's the second one. Now, so you can, like ComCheck, the new 2022 ComCheck does work with Chapter 11. I just wanted to point that out to you at this page. So you can put in the things and you can show your, it'll ask you for those efficiencies. All right, so here is that the math you would have to do to use HO3. So it gives you a little equation, HO3 base times the lesser of the percentage improvement is a fraction of cooling efficiency requirements up to 20%. So you could start with 5% and you could go as high as 20%. So if you used IE of 20 right here, you would, and 12 is your base, 12 is your base, 20.2, 20% is your where you got to, then you could get as many as 48 points from this one change. You'd have to find a piece of equipment that was 20% better than what was in our table, which is possible sometimes. And there you would go. You would get 48 of the 50 points that you needed in that one thing. So you could do the controls and this, and you would be through. Now, if you wanted to do the envelope improvement, it actually, you go to Appendix C and it has a little simulation calculation that you have to do. So you have to actually run a little model to get that done. Now, to tell the truth, I haven't looked to see if ComCheck would run that model for you, and you would just have to enter some of these numbers. That'd be interesting. I need to check that. But anyway, that might make that much simpler. But this is the most complicated. If you're just doing the problem, you do have to run that little model. So it is the hardest points to get as far as your work is concerned. So then, after you do all that stuff we just talked about, after you get finished with all your calculations, you may have to make an adjustment. So if you didn't, here's the exceptions for renewables. So you were supposed to use 0.5 watts per square foot, but if you had a building that was located where an unshaded flat plate collector tilted towards the equator would only get this much. So you're in an area that just doesn't get much radiant heat from the sun. Building where more than 80% of the roof is covered by equipment, where you can't put them up there. Any building where more than 50% of the roof is shaded from direct beam sunlight, or other structures more than 2,500 annual hours between 8 and 4. New construction or additions where the sum of the gross condition area of the 3 largest floors is less than 10,000, smaller building, then or if you're doing alterations, we don't force you. So these are the exceptions. If you took any of those exceptions, then when you get to section 11, you're going to have to make an adjustment based on to correct your energy savings or your adjustment credits. Now, or your credits, extra credits. So anyway, the cause is there's a big deal about each one of those points, no matter if you're doing an HVAC or envelope or lighting, are equal to the same amount of savings. Now, if you did, and that's based on the calculation for the total building energy. And the total building energy has been reduced by the amount of on this 5 watts a square foot. Now, if your actual building didn't get that reduction, then your points aren't the same value as the buildings that did get all of it. So you have to go back and do this adjustment. And this adjustment is, just happens that 12 is the same number, but that doesn't tie to the other 12 we were using. And then you stick it in this equation, and you needed 50 points, and that goes here, 50 required, and the PV adjustment was 12. Put that in there, and then how much ever you had to adjust, because you use less radiant heat, horizontal projection of rough available, for any of the reasons you use less net value or less floor area, actual floor area, You put that in there, and then you make your adjustment. And it turns out that if you play with the equation, you're actually going to need less points, but I think each point is worth a little more. But anyway, your adjustment will change, and you'll have to do that extra work to get through that. So let me check. I know that was a little, doesn't look like we have any questions. So I'll tell you, we're in a little trouble because I have run out of slides. I had extra slides to do today, but I must have took off this morning really fast because we're at the end of the show and it's 1:38, so we got 22 minutes, 38:40. We got 22 minutes left now. So this is my Wise Watt. This is my email address, and I do take emails. Now, if you want questions, it's a great time to do it because we've got some time here to talk about things if you would like to. And that's why I allow this much time for questions. But actually, I think I went a little fast. Now, last time I did this, I had to really rush at the end. Sorry about not giving you your full time, other than if you'd like to ask some questions. I encourage that now. Think I missed something? Want to go over anything? We can look back. You do have a few more slides talking about ASHRAE, but I think that's what confused me. I got 5 more slides. Questions? Nope. All right. So, Ryan, you want to take over? Are you there? Probably not there yet, because why would he be listening at this point? Okay, I'll do my best. So this is our president. This is our new powering our workforce, building a sustainable future. So this is his presidential effort or focus. He does one of these, or you can get to one of these through these. You can get through his presentation through either one of these details. Dwells in the question by highlighting the emergence of new technology in the industry, explores the imperatives to remain adaptive, which we are. We're early adapters of this stuff, and forward thinking in shaping engineers, building scientists in the future. So
Yes.
Is 9.1 still looking for a volunteer? That one just came. Well, we're always looking for new, for people that have special interest in 9.1. It is something that you go to the website. And did I show you how to comment? Well, I think I told you how to comment. Anyway, you go to the website and you fill out a form and you say, I want to participate. And that gets you in a queue to be able to be reviewed by the chair of the committee. But the best thing to do is to simultaneously come to a meeting. Now, if you go to the winter meeting, the summer meetings, those are the best places. You can come to Atlanta. Next week, there'll be a meeting in Atlanta. So we have a quarterly meeting, 90.1. And if you show up, shake hands with them, talk to them, say, I'm interested in going and listen in and show up a couple of times. At the same time, you've got your application in, then it shows your interest. And mainly, we want people that are actually going to, not show up to the meetings and participate. And generally what will happen is if you'll go to a subcommittee meeting especially, you can get on a working committee and you can be able to help build, help write one of the changes or be involved in one of the changes. And then you'll get onto the subcommittee first. And so then they'll get on subcommittee and you'll be a voting member of a subcommittee. Like I'm a voting member of the mechanical subcommittee. And then out of that group, if you participate and do well, then you'll be made a voting member of the full committee, which is, I'm one of those too, but it's a little harder to get to be a voting member of the full committee. You have to put a little effort into that. Now, the only exception to that is if you happen to be an organizational member. So like, the EPRI and some places like that have members that come on real fast because that piece of industry they want represented. And if you have some kind of special connection like that, it would help. But anyway, there is constant turnover in the committee, and there are new people joining all the time. But it's mostly, again, we have 2 of the meetings are in-person / virtual. We are still running all 4 meetings with the chance to call in, left over from the COVID days. But you're strongly encouraged to show up, especially to the 2 meetings that are during the conventions, the winter and summer conventions, because we have very big participation. Now, again, there's a little more leniency in the 2 that happen in Atlanta. They go to the ASHRAE office building, and all of our meetings are from start on Fridays, and they go Friday, Saturday, and Sunday. And then the ones in Atlanta get off at noon on Sunday, and the ones at the conventions get off at noon. It's kind of what committee you're on, but like the mechanical committee meets pretty much at least 8 hours a day during that time period. So it's a big commitment. And then we have like the mechanical subcommittee has a monthly phone call that lasts 2 hours. And then if you're on a subcommittee, that'll have another phone call. So I'm on the mechanical subcommittee, which has the monthly phone calls. And then I'm on the decarbonization working group, which has a monthly call. And then you're supposed to be ready for those meetings by doing work. It normally only meets those 4 times a year. Now we've had, and we will have, because of the as we get close to having to print the document, we'll have another set. We'll have some full committee calls for special things and to get finished with our work as we get close to our deadlines. when we have to have this out. But it is a good, I mean, you are obviously, especially for the next 9 years or what, you're really going to be changing the industry and making all the rules for the least efficient building built in America that'll be net zero carbon. So it's kind of an exciting time to be involved. Any other questions? Allowed a little bit extra time for questions than I did need, I guess. But no, I think I started talking too fast maybe earlier in the day, because I had yesterday went fine, and I had about 10 extra slides to do today, and somehow I finished real early, so, or a little early. Anyway, that's all I got.